In order to quantify sustainability, we need to use a method. So there are different types of methods available, and in this session we're going to discuss three of the most important ones for your career. So these are the energy analysis, the ecological footprint analysis, and the life cycle assessment. The energy method has been developed over the last 3 decades and is a tool for environmental policy and to evaluate quality of resources in the dynamics of complex systems. So Odum identified the work of biosphere driven by solar energy as the source of resources and environmental services and provided a common measure of them, which is called solar energy. So Odum suggested that energy to be the basis for value and sustainability assessments. So in short, energy is defined as the sum of all inputs of energy directly or indirectly required for a process to provide a given product when the inputs are expressed in the same form or type of energy. Usually is solar energy. So most often inputs to a process are the result of another processes or a chain of other processes in which energy has been concentrated and upgraded. So energy is then the sum of all these inputs. So the energy methods gives a sort of evaluation of the cost, the real cost to produce wealth. We have state that all sources of energies are coming from the sun, except geothermal energy, of course. In this figure, we have the energy captured in a tree, and then this tree is the wood or the material is extracted, and this has an economic value. So therefore, this method can be used for assessing environmental sustainability, but also the carrying capacity. So how much of goods and services the planet can supply also in a renewable way. Also, it helps companies, for instance, for environmental decisions, because it helps to plan how to use the available resources. Within the energy method, we're going to have 3 important concepts. One is transformity, the second one is renewability, and the third one is environmental load. Renewable energy sources are the constant and the recurring energy flows of the biosphere that ultimately drive the biological and chemical processes of the earth and contribute to geologic processes. Sometimes resources that result from these energy sources, like wood or biomass, are considered renewable resources. For example, a forest or biomass materials in general. In this case, to be renewable, the replacement time must be at least as fast as their use rate. Otherwise, it will be considered non-renewable resource. So then, as examples of renewable resources, we can have the sun, tides, deep heat, rain, etc. And as examples of non-renewable resources, we can have topsoil loss from erosion, we can have fossil fuels, and we can have biodiversity. Transformity is a measure of the convergence of energy flows to provide a given result. It is an indirect measure of the renewability of a final product. The more energy that is converged to produce a resource, the longer the replacement time, and the higher its transformity. So here we have an example of the energy required to produce meat. So we have the sun, that is the energy provider for the pasture, and then we have the cow that takes this energy from the pasture, and then we have all the things that are required to get the meat to the final end user, which is the man. In these processes, energy will be required for every step, right? And in the diagram that is below this figure, you can see that we have outside the box the renewable energy, that is the sun, and inside the box we have the minerals and the water and soil that are considered non-renewable. And then we have the pasture and the process from pasture to cattle and then to men. So if we follow that logic, it means that we can account for energy required for anything. So even human labor, we can quantify in terms of energy units what is required to do the activities that we do on the daily basis. So as you will see, the method is quite useful and it's quite insightful because it also considers time in terms of sustainability. So what is sustainable in one time period may not be sustainable in the long run. So for instance, economies like developed countries have a high growth phase that was characterized by the extensive use of non-renewable resources that allow them to have a good economy. But then on the long term, this is not sustainable, and now they have to rely on non-renewable resources, right? But then the nice thing of the method is also that considers imports of energy. So it considers imported resources. And for instance, nowadays, developed countries tend to import goods with very high energy created from non-renewable resources in order to maintain the economic growth that they have now without compromising their sustainability standards, right? But the increase of imported goods decreases the sustainability index within this method. Another nice thing of this method is that it reflects the inefficient energy and material use through a high energy value for the product Y. So if you look at the figure, and the figure says the sum of all these energies coming from imported resources, renewable resources, and non-renewable resources gives a final Y product. Y is energy of product or yield, and is the sum of these three streams. This sum may not be totally true because if you see on this figure, the symbol that is below of the figure indicates the irrecoverable energy such as waste heat. So you may know that R plus N plus F cannot be equal to Y. But it doesn't matter. We have to emphasize that we're talking about energies and not energies. Based on the construction of these diagrams and on these energy values, we can come up with some indices, or what is called performance indicators. This can be the percentage of renewable, and is the percent of the total energy driving a process that is derived from renewable resources. And then, so this one actually is a good indicator of if we are going towards sustainability or not, because on the long run, we expect that all the process will be relying highly on renewable resources to be sustainable. We also have another indicator, that is the non-renewable to renewable ratio. And if this ratio is high, it means that large amounts of non-renewables to relatively small renewable flows of energy. We also have another indicator, that is the energy yield ratio, and it is an indicator of the yield compared to inputs other than local, and gives a measure of the ability of the process to exploit local resources. We have the environmental loading ratio, and this is a good indicator of the pressure of the process on the local ecosystem, and can be considered a measure of the ecosystem stress due to production activity. We also have an indicator that is linked to economy, which is the energy investment ratio, and this is it gives an evaluation if the process is a good user of the energy that is invested in comparison with alternatives. And then we also have indicators of sustainability that are the focus of this discussion. So we can have a sustainability index that can tell us that is also a balance of the non-renewable, renewable, and the import of energy. The energy method by itself is not sufficient to measure sustainability of a product or of a process in general, because high energy inputs can be totally or almost totally renewable and still can cause environmental problems. So, for example, the energy method does not look at the outputs of systems. So it only considers the inputs of into the system of energy as energy, right? But negative outputs of systems can include CO2 emissions or NOx or other type of emissions, including heavy metal elements that are not accounted in, are not considered in the method, right? These negative outputs can lead to environmental impacts such as global climate change, eutrophication, or acid rain. But on the other hand, these outputs can also be wastes that can get into the system again, like can be recycled or can be used on other streams. To better understand this method, I'm showing you a general example of crop production that shows the basic processes of accounting for the energy flows and the unit energy values. So the first step to use this method is to design an energy flow diagram of the system and identify all areas of energy use and also their relationships and categories. Then different inputs of the evaluated system are recognized and converted into energy evaluation tables by multiplying by unit energy values. The unit energy values refer to the energy required to obtain a unit product or service. And the units of this UIV is solar energy. So for convenience, people use the same values that has been already found for resources and commodities in other previous calculations. So we can already use these values. So once we have like a list of the values, the energy values, we can put them in the right allocation within the diagram, which are if these ones accounts for renewables or for non-renewable resources, for imported products, or if they go to one process or the other one, right? So in the diagram, R is the renewable environmental resources such as sunlight, rain, wind. N is non-renewable environmental resources such as the soil and groundwater. M1 and M2 are materials from economic systems such as the mineral fertilizers, pesticides, labor, etc. And that's it. Then we will have a final product, and we can also have the yield for each of the processes.